Objective 12.8, Samples. In Objective 12.8, we want to be able to identify different sampling methods for collecting data and interpret how they affect the results of a survey. We also want to be able to find the margin of error of a survey based on sample size. So let's start with a little bit of vocabulary. When you are taking a survey, you have a population of people that you're interested in and a sample of people that you're actually going to survey. So the population is a group of people or objects that you want information about. A sample is a subset of that population. So usually you are in a situation where you are not able to interview or to survey everyone in the population. So you survey some people in the population, and that smaller set of people is called your sample. Now there are 4 different types of samples that you can generally use. One is called a self-selected sample. In this sample, members of a population can volunteer to be in the sample. You also have something called a systematic sample. In this case, a rule is used to select members of a population. So for example, if you were to pick every other one from a list of people's names, that would be a systematic sample. A third type of sample is called the convenience sample. This is a sample of people who are easy to reach members of the population. So they're easy people for you to be able to survey and to talk to. And finally, we have a random sample. And in this sample, every member of the population has an equal chance of being selected. So there's no particular rule to it. You're not just going out and talking to the people who are the easiest to get to. You're not just allowing people to volunteer themselves to be part of the sample. You are actually randomly picking people to be part of your survey. So let's see if we can classify some different situations as to what type of sample they are. In this problem, we have a sports writer who wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. So we want to identify the type of sample that's described. So here's our first type. The sports writer contacts the coaches that he has cell numbers for in order to get quick responses. What type of sample would you classify this as? Well, hopefully you realize this is a convenience sample. If he has cell numbers for these coaches, then that makes them easy to reach people to become part of his survey. So this would be an example of a convenience sample. How about this one? The sports writer mails out surveys to all the coaches and uses only the surveys that are returned. This would be an example of a self-selected sample because the coaches are choosing whether to volunteer themselves for the sample by whether they mail the survey back in or not. Now, samples can also be classified in terms of bias. If you have a biased sample, then that means there's some part of the population that is going to be overrepresented or underrepresented. So it's not a good mix of people based on what your population is. So an unbiased sample is going to be representative of the population you want information about. So for example, if you want information about the entire high school, but you only ask the seniors for their opinion, then that would be a biased sample. It overrepresents the seniors and underrepresents the other grade levels of the school. So if your population is meant to be the whole high school, you would want to make sure you have a representative sample of the whole high school. So generally speaking, you will draw more accurate conclusions about a population from an unbiased sample. And usually a random sample is the preferred because it is most likely to give you a representative population. Now, it's not the only way to get an unbiased sample, but it is the most reliable way. And that's what you want in your surveys and in your samples, an unbiased sample so you can get the most representative results. Okay, so let's take a look at this situation. The manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. So in this situation, there's 3 questions I want you to answer. What is the population he's interested in? What type of sample did this manager use? And would you consider this sample to be biased or unbiased, and why? Well, his population is right here. It says the manager of the concert hall wants to know how often people in the community attend concerts. So his population is the community that he's in. His sample then are the 50 people standing in line that he talked to. What type of a sample would you say that is? I think that would best describe a convenience sample. He walked outside of the concert hall, he asked people in line, they were easy to get to, and so this would be an example of a convenience sample. Now, do you think that this sample would be biased or unbiased? And why do you think that way? Now, when you have a question like this on a quiz or a test, as long as you can give me a good reason why you feel the way you do, then I will give you credit for it. So there's not necessarily always going to be a specific right or a specific wrong answer to this. Okay, some samples are a little more obvious than others, but again, the key to this will be your reasoning. If you can give me a good reason, I'll take it. In this case, I would say that this would be a biased sample. Because if he's talking to people who are already in line for the concert, these are people in the community who are already likely to be concert goers. And so their number of times going to a concert is probably a little higher than some of the other people in the community who he hasn't talked to at this point. And so the concert goers are going to be overrepresented in this particular sample. So that would make this a biased sample. So how do you get random samples then? If that's the best way to go, how can you do that? Well, here's one way that you can set up to get a random sample. First, you would need to get a list of your desired population. So everyone in the population you're interested in would need to be on a list for you to use. And then you would assign each number on that list a unique sequential number. So if you had 50 people on the list, you would just number them 1 through 50. And then you use something called a random number generator. And most graphing calculators have this function on it. It's usually something like RANDINT, and then in parentheses you say you want to go from 1 to whatever n value, and your n will correspond with your population. So again, if you have 50 names and you've assigned them the numbers 1 through 50, then you would be using 50 as your n here for your population. And then you just hit the enter button however many times you want for your desired sample size. So maybe you want to ask 20 of the 50 people. So you would just hit the enter 20 times, and record the numbers that come up in this random generator. If you get any duplicates, you just disregard those and hit the enter another time to replace that number. So you're getting 20 different distinct numbers that you can use for your sample. And then you go back to your list where you numbered these people, and those are the people that you will choose. The numbers you got from your generator will correspond to the people or objects on your list, and they will become your sample. Now that's a very techie way of getting a random sample. You can also do this in a very low-tech way. For example, the old put everyone's name in a hat and draw them out. That is another way of getting a random sample. So there's different ways of doing this, but it is the best approach when possible. Now within a particular survey, you will have a margin of error. So when you're conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. As your sample size increases, the margin of error is going to decrease. So you want to make sure you're asking enough people to really get a good idea what the responses would be like. And the more people you ask, the margin of error is going to get smaller. The margin of error gives you the limit of how much the responses from your sample are going to differ from the responses of your population. So you'll see this a lot of times if you're watching the news and they give you the results of a survey, especially during an election season. And they'll say that, Romney is at 28% and Obama is at 34%. But then if they tell you the margin of error is a plus or minus 3%, then that really means Romney could be as high as 31%, or Obama could be as low as 31%. So it really could just be even Steven. Okay, so that's what that margin of error is telling you. Based on how many people were asked, they're telling you how much the responses could be off to represent the entire population. So how do we find the margin of error? Well, when a random sample of size n is taken from a large population, then the margin of error is approximately equal to this formula. Now this works best if you have a large population to start with, and again, hopefully you're taking a fairly large sample of it. And so you can figure out the margin of error by taking plus or minus 1 over the square root of n. And again, n is the size of your sample. What this means then is that if the percent of the sample responding a certain way is p, then the percent of the population that would respond the same way is likely to be between p minus the 1 over square root of n and p plus the 1 over square root of n, where we have taken plus or minus 1 over square root of n and changed it to percent form. So once we figure out this margin of error and we change it to a percent, then we want to subtract it from the percent of our sample and add it to the percent of our sample in order to get the limits or the range within which the population probably would answer the same way. I know that sounds really complicated, but it's really not. So let's take a look at an example. So here we have a survey of 1,011 people. And 52% of those people said that television is their main source of news. And you can kind of see how the other sources fared here in this particular survey. Okay, so what is the margin of error for the survey? Well, since we surveyed 1,011 people, that is going to be our sample size, and that is going to be our n. So we stick it into our formula here, And what I forgot was that this should be plus or minus out here in front. So we take 1 over the square root of 1011. We work that out and we get a decimal of about 0.031, which is going to become a percent of about 3%. And again, this is plus or minus 3%. Okay, so then we're being asked to give an interval that is likely to contain the exact percent of all people who use television as their main source of news. So now we take the 52% that we got from our sample, and we're going to subtract 3% from that to get the lower limit, and we're going to add 3% to that to get our upper limit. So we would expect that the percent of all people who get their news from the television would be somewhere between 49% and 55%. 52 minus 3 is 49. 52 plus 3 is 55. So that's how margin of error works, and that's what we were just explaining on the previous slide. So it's really not that complicated. As long as you set up this formula to find the percent, then it's just a matter of adding it and subtracting it to your sample response to get an overall response of what you expect from the whole population. All right, so that gives you the information you need for this final objective for Chapter 12. Don't forget to go and complete the 12.8 quick quiz on the mentor mob. Then you can work on the 12.8 practice and make sure you get everything checked off when you're finished. And then you can get ready for your last quiz, the 12C quiz, and start working on preparation for Chapter 12 test. If you have any questions, make sure you ask when we meet again next class. We'll see you then.